Hello. Okay, so for reasons I don't need to get into, I'm currently learning about logic, Boolean algebra, and digital circuits. Literally 2 weeks ago, I would have struggled to tell you anything about Boolean algebra. But thanks to a couple of brilliant games and inspiring communities, I'm starting to wrap my head around it. I don't intend for this video to be a tutorial. If you want to understand these concepts and processes, I'd highly recommend watching Matt Batwing's brilliant series called Logical Redstone Reloaded. He teaches the concepts in Minecraft, but also breaks down and explains Boolean algebra, binary, logic gates, and lots more, and he does it really well. In this video, I'd like to show you the 4-bit ripple carry adder I built in Robot Odyssey. If you don't understand what that is, don't worry, I didn't either. All will become clear, or clearer, I hope. So I started learning this stuff in a game called Turing Complete on Steam. Each puzzle explores another concept of digital circuits, and although it's great and I would recommend it, I did have to watch some videos on logic gates to develop my understanding enough to even be able to take on the second puzzle. If you've never seen a logic gate before, like I hadn't, then having to explain a NAND gate as the first proper puzzle was a bit much for me. However, with this video's help, which I've linked below, I was able to get my head around it. At the same time, I found Robot Odyssey, a game published by the Learning Company in 1984, and I instantly loved it. You can play the game for free online, and I would recommend you do. In the game, you wake up one normal morning, fall out of bed, straight through the floor, and end up in the sewers, where you find 3 robots you have to rewire to solve various puzzles and get back to the surface. I haven't actually got round to playing the game yet. I've been mainly going through the tutorials and playing in the sandbox they call the Innovation Lab. So I was watching Matt Batwing's recent series on building a computer in Minecraft. His videos are amazing, and he shows how you can build a computer that can play Tetris, Snake, and other games using redstone circuits. I've played Minecraft a bit, but not like this. My son and I once made a rocket and a space station together, that kind of thing.
Request denied.
So I started following along with the video and recreating the basic circuits and logic gates, and it got me to thinking about whether I could recreate these circuits for myself in Robot Odyssey. My first notable achievement is building a 4-bit ripple carry adder, or RCA. This allows you to add 2 4-bit binary numbers together, like the world's most simplistic calculator. You do need to understand binary a bit. Here's a very brief explanation. In the decimal system, we have 9 symbols that are used to represent all numbers, 0 through 9. We use something called positional notation, which says that numbers have different values depending on which column they're in. That means a 1 in the right-hand column is worth 1, but in the next column would be worth 10, and in the next one would be worth 100. etc. So a number like 123, 123, means 1 times 100, add 2 times 10, add 3 times 1. Binary works the same way, but with only 2 digits, 0 and 1. So instead of each column being 10 times greater than the number to its right, it's 2 times greater. So the first column would be worth 1, the second column is worth 2, the third column is worth 4, then 8, 16, 32, etc. So in binary, 1 would be 1, 2 would be 1, 0, 1, 2, and no 1s. 3 would be 1, 1. So to build an RCA in Robot Odyssey, first we need to build a full adder. This is a circuit that can add 3 binary inputs together. Again, Matt does a far better job of explaining this than I would, so check out his video explaining adders. This is what the circuit looks like for a full adder. In the Innovation Lab, you can use computer chips and your toolbox full of logic gates to create complex circuits for your robots. These can then be used to help you solve puzzles in the game. As I said, I haven't actually got around to playing the game yet, but that's what the manual says. The pins on the computer chip can be inputs or outputs, depending on how you wire them. So we're going to make these two our A and B and take them into our first XOR gate and the first AND gate. The output of this then goes to a second XOR gate and second AND gate. Input C, the carry in, also goes to the second XOR and second AND gate. Now the output of the XOR is the sum, and if we take the outputs of the two AND gates into a final OR gate, this will give us the carry out. And this completes our full adder. In the Innovation Lab, you can burn chips to make copies of them. So each of these chips is now a full adder. I'm using these flip-flops as inputs. Again, maybe I'll find a better way to do this, but I was literally clueless when I started, and there are very few videos on Robot Odyssey that I could find, which is partly why I'm making this. Now all I need to do is chain these together to make the RCA. These flip-flops, or whatever they are, allow me to turn the current on and off by only wiring up one side of it. So I wire 4 of these up to the A's, which together form my first 4-bit number, and then another 4 to the B's, which form my second 4-bit number. The limitation I found was there are no obvious components to use as outputs for the circuit. In Minecraft you use lamps that light up when they receive signal, which you have an infinite amount of. In Robot Odyssey, these circuits are meant to be designed to use in 3 robots which have limited places to output signal to. You can output to the antenna, which beeps when you get a signal but not inside the robot, a grabber, which picks things up when it gets signal, or to the thrusters, which propel the robot with a signal. And that's it, as far as I can tell. So I've ended up using NOT gates for my outputs. Again, if you know a better way, I'd love to hear it. So here it is, my completed 4-bit ripple carry adder. If I add power to the flip-flops over here, you can see the sum of those inputs on the NOT gates. So for example, 1 add 1 equals 2, 8 add 5 equals 13, 8 plus 8 equals 16, etc. I've started learning about cancel carry adders now, so I might make another video if and when I build one of those in Robot Odyssey. There are lots of videos that show you how to do this in Minecraft already. And then some kind of clever sign-off where I convince you to watch more of my content, or subscribe to my channel, or come and say hello in the comments, or something else witty and insightful, but endearing and friendly. No, I haven't got it.